Good afternoon. This is the Chem 101 third hour exam missed problems review video. I have in front of me a select list of problems that were missed commonly by many students on the exam. All I'm going to do is go through those select problems that I've chosen. If you have other problems that you want an answer to that I don't cover in this video, please make sure you make an appointment to get time with me in my office during my office hours or do a Zoom session so we can get your questions answered. So the first problem is, let me see, problem number 3. Of these, which represents a condensed structure of a 4-carbon hydrocarbon molecule? A condensed structure is that representation that shows all the elements explicitly shown that are present, but it does not show connectivity. So this is a 4-carbon structure. 1, 2, 3, 4. This would be an expanded structure because every element is explicitly shown. All the bonds that are to each element are explicitly drawn in for you. So we know that this carbon is bonded to this hydrogen, that hydrogen, that hydrogen, and that carbon. So this is an expanded formula. This is a skeletal formula. Skeletal formulas are those where lines start, meet, or end, there's a carbon. So we've got a line starting carbon, lines meeting carbon, lines meeting carbon, lines ending carbon. So this is a 4-carbon molecule, but it does not show you the attached hydrogens. It assumes that you know that carbon is bonded to 4 things. This carbon is explicitly shown only bonded to that carbon, but it assumes that you know that there are 3 other hydrogens attached to that carbon there. Number B is a molecular formula. Molecular formula just tells you how many carbons there are and how many hydrogens there are. It gives you no information about how they are attached to one another. So the best answer, the correct answer for this condensed formula is A. Number 4. Number 4 asks, which of the following compounds are secondary amines? Secondary amines are nitrogen-containing compounds that have 2 carbons attached to the nitrogen. So in compound A, are there only 2 carbons attached to this nitrogen? There's 1, 2, 3. No, that's a tertiary amine. Number B, there's a nitrogen. How many carbons are attached to it? 1. That's a primary amine. This is not an amine, this is an amide. Here down in E, how many carbons are attached to that nitrogen? Again, 1. This is the primary amine. Here in answer D, how many carbons are directly attached to that nitrogen, that carbon and that carbon? This is a secondary amine. Next problem. Number 12. Which of the following molecules is a typical fatty acid? Molecule that has an even number of carbons in a branched chain? No. An amphipathic dicarboxylic acid with unconjugated double bonds? No. A polar hydrocarbon that reacts with sodium hydroxide to form a salt? No. The answer here is a typical fatty acid that we find is a molecule that has usually 1 cis double bond in a long linear straight hydrocarbon-like chain. That was number 12. Number 16. 16 asks, of these compounds, which of these compounds are constitutional isomers of compound A? So this is our comparison point. Well, let's look at this. How many carbons are present here? 1, 2, 3. C3. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. So C3, H8O. Well, if they're going to be constitutional isomers, they have to have the same molecular formula. What about this guy? 1, 2, 3. 3 carbons. How many oxygens? 1. 1, 2, 3, 4, 5, 6, 7, 8. So C3H8O. What about C? 1, 2, 3, 4. C4H1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10O. Well, this is not a constitutional isomer just simply because it does not have the same molecular formula. Let's look at this one. How many carbons? 1, 2, 3. How many oxygens? 1. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. So C3H8O. What about this guy? Carbons, 1, 2, 3, 4. How many hydrogens? We've got 1 oxygen. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10O. This is not a constitutional isomer. What about F? 1, 2, 3. C3O. 1, 2, 3, 4, 5, 6, 7, 8. C3H8O. So those compounds that are isomers of one another have the potential to be B, D, and F. Constitutional isomers are those compounds that have the same molecular formula, but the backbone of the molecule is arranged differently. Here we have 1, 2, 3. We have 3 sequentially arranged carbons. 1, 2, 3. 3 arranged carbons. 1, 2, 3. 3 carbons. Constitutionally, are these arranged differently than that? Yeah. Here we have the OH on the end carbon. Here the OH is in the middle carbon. So how the arrangement of things on this, these are constitutional isomers. Here, do we have things arranged differently? Yes. 1, 2, 3. Instead of an OH hanging off either end or the middle, we've got the oxygen now in the linear sequence of atoms. So B and D, F is an isomer of A. So the answer here should be B, D, and F. Next question. Number 17, it should read, why are ethers more volatile than other alcohols having the same molecular formula? Do ethers have dipoles? Yes, but so do alcohols. Alcohols do not have resonance structures. You don't need to worry about that one. You never talked about that one. Intermolecular hydrogen bonding in ethers. Hydrogen bonding requires that there's a hydrogen directly bonded to an oxygen in an ether. You have a carbon-containing group bonded to an oxygen bonded to another carbon-containing group. So in ether, you have no potential for hydrogen bonding. But you do have potential for intermolecular hydrogen bonding in alcohols. So 17 is D. Number 23. Which molecule is chiral? Molecules that are chiral have a carbon somewhere in them that has 4 different things attached to it. Since we're looking at skeletal models, carbon, 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 carbon. There's 2 hydrogens here, 2 hydrogens there, 2 hydrogens there, 2 hydrogens there. None of these carbons are chiral because none of these carbons have 4 different things attached to it. This carbon has an an oxygen, a hydrogen, but CH2, CH2. We go one further, CH2, one further, CH2. This carbon has 2 identical things attached to it. This and that. Those are looked at as identical. That carbon is not chiral. This carbon has CH3, CH3. This carbon has 3 identical things to it. That carbon is not chiral. Hydrogen, hydrogen. That carbon is not chiral because it has 2 hydrogens attached to it, which are identical. CH3, CH2, CH2. This carbon is not chiral because it has 2 identical CH3s attached to it. We look at number C. CH3, CH2, CH3. That carbon is not chiral because it has 2 CH3s attached to it. This is CH3, that's CH2. This guy right here is chiral. It has 4 different things attached to it. It has an oxygen, it has a hydrogen, it has this ethyl group, and it has this 3 carbon fragment. This is a 2 carbon fragment in an ethyl group. This is a 3 carbon fragment, a propyl group. So this carbon has the hydrogen, the oxygen, a 2 carbon fragment, and a 3 carbon fragment. Answer C is chiral. '23. Number 30. Heating a carboxylic acid with a primary amine forms water along with what product? So, carboxylic acid. Heating it with a primary amine produces water And what organic product? Well, if we lose water, where can we come up with water? Well, if we look at water as HOH, here we have an H and ROH. If you look at the immediate last problem, number 29, you can replace C with an amine. So this is the kind of reaction we're doing. So we are heating carboxylic acid here with a primary amine. Primary amine is something that has one carbon to it. You produce water, and the nitrogen ends up being bonded to your carbonyl carbon. This is now no longer an amine. This is a C double bond ON, an amide. How many carbon containing groups are bonded to the amide nitrogen? 2. So that makes this a secondary amide. Number 30 and number 32. Clavulanic acid, structure shown below, is a drug used in conjunction with some antibiotics to overcome certain types of antibiotic resistant strains. Of the functional groups listed below, which one is not contained in clavulanic acid? Carboxylic acid, C double bond O, OH, a beta-lactam, a cyclic ring system, C double bond O, with a nitrogen attached to the carbon of the carbonyl. The nitrogen and the carbon are connected in a ring structure system. A lactone, is a cyclic ring system, C double bond O, O, with this carbon group connectivity circling back to itself. An ether is a carbon oxygen carbon containing bond. So do we have a carboxylic acid? Yes. Carboxylic acid, A. Do we have a beta-lactam? Here is your beta-lactam, your C double bond O connected to your nitrogen, which ultimately cycles back around to the C double bond O. There's your C double bond O bonded to your nitrogen. Your nitrogen ultimately cycles or circles back around to get back to your C double bond O. That's your beta-lactam. Does this have a lactone? Do we have a C double bond O bonded to an oxygen? Well, this C double bond O is bonded to a carbon. That C double bond O is bonded to a carbon or a nitrogen. Do we have a C double bond O anywhere else in the molecule? No. Do we have an ether? Yes, we do. Here we have one carbon containing group bonded to our oxygen, bonded to a different carbon containing group. So the answer here is in clavulanic acid, there is no lactone. All the other functional groups are present in the molecule. And let me see, was that it? Yes, that's it. So this is the review. If you have any other questions that I did not specifically investigate or go over in any detail about in the exam, please email me, set up a time that you can get back to me in my office, or we can have a Zoom session to chat about the problems that you have questions about. Thank you very much. See you tomorrow in class. Bye-bye.